Hi guys, we are over at Noctua. Jakob's going to be taking us through a new product that we're going to be having a look at. This has been 4 years in the making, and that is due to the engineering and the new material which is being used. So he's going to talk us through this now.
Yeah, as you've said, this has been our most in-depth, most intricate fan development project ever. Next generation 120mm by 25mm A-series fan. What makes this fan so complicated and so delicate to manufacture is that we're aiming for a tip clearance, that is the distance between the tips of the blades and the inside of the frame, of only 0.5mm.
Okay. Why would you want to get so close to the frame? What, that distance? What's the reasoning behind that?
The reasoning behind it is that when a fan pushes air against a heatsink or a radiator, it creates pressure. And due to the back pressure, air will leak back through this little gap, and instead of being pushed through the radiator, it comes out the other way.
Okay.
So the bigger the gap, the more leaks flows you will have, and the narrower the gap, the more air you can push through your heatsink or radiator. So this is why you want that gap to be as small as possible.
Okay. And anything else you can tell us about why it's taken so many years to sort of produce, engineer, research the materials behind it?
Yeah, the obvious downside of choosing a smaller and smaller gap size is that the tolerances get smaller and smaller. And most importantly, we're facing a problem that's called impeller creep. If you have a fan running for many years, due to the centrifugal forces, the impeller will grow slightly bigger.
How many years are we talking, or months?
We're talking about something like 5 or 6 years of usage.
Okay.
And you will see only a minute growth, something like 0.1, 0.2mm, all depending on the blade design, on the rotational speed, on the temperatures. But this is not a problem with your average fan, which may have a gap of, say, 1.5 or 2mm. But if you only have 0.5mm, if your impeller gets bigger by 0.2, you're very close to serious trouble. So this is something we had to avoid at all costs. Yeah, the obvious question is, how did we avoid it? And in the end, we ended up creating our own plastic material. We call it Sterox. It belongs to the family of liquid crystal polymers. You may be familiar with Kevlar, which is the most well-known type of liquid crystal polymer. It's used for bulletproof vests, helmets, things like that. So you can already guess that the main advantage of this type of material is its extreme rigidity, very high tensile strength, and this is what allows us to manufacture a fan with such strict tolerances and such a small gap.
So obviously it's a lot more rigid in terms of you can feel that in your finger compared to a normal fan. Any other different properties, advantages to using that material?
Yes, there's a second key benefit we get from using the Sterox LCP, and that is better vibration dampening properties. Like every flat surface, a fan blade has a natural resonant frequency, and when you have turbulences of the air across the fan blade that hit that resonant natural frequency, you will create vibrations that translate back to the air, get transmitted back to the air, and that change the acoustic profile of the fan for the worse. So the stiffness of the material allows us to better dampen these vibrations. We have a little graph here showing nicely how the same impeller manufactured from our standard fiberglass reinforced PBT, after initiating the vibration, takes quite a while until fully dampening the vibration, whereas the Sterox LCP can dampen the vibrations very, very quickly.
And obviously this is a completely different material that you're using here. Is it going to cost more money?
Yes, the big downside of this type of material is the cost. We're talking about roughly 4 times the raw material price of our standard PBT. So unfortunately, this fan is going to be quite a bit more expensive than our current 120mm models.
Roughly how much would you expect?
We're aiming at an MSRP of roughly 30 USD, 30 euro at the moment.
And that's 120 millimeters?
Yes, that's for the 120. It's always important to stress that each different form factor is basically a completely new development. We can translate some design patterns, some aspects of the design from one size to the other, but it's not like you can just take one design, upsize it, downsize it. This would lead to horrible efficiency. You have to do a lot of fine-tuning when you make a step from one form factor to the other.
Okay, now we've got a live demo of this new fan that they've been developing. Before we do that, I just wanted to ask you, we've got a great graph behind us showing us the type of application that this is good for. You know, we talk about pressure, or we talk about airflow with the fans that you've had in the past. With this fan, what is it more suitable for?
Yes, this is something we need to talk about because it's a very important question. The new A-series fan is neither a pressure-optimized nor an airflow-optimized fan, but it's not a compromise either. It's basically an all-rounder that really excels in all typical applications. And in order to understand why this is the case, this graph is very helpful because it shows that our NFF12, the green line, actually has higher maximum pressure than the yellow line, that's the new A-series fan, and that our airflow-optimized NFS12A actually has higher airflow, higher maximum airflow than the new A-series fan. But it's important to explain what maximum pressure and maximum airflow specifications actually mean. And for maximum pressure, this is always given at zero airflow. So this is like the fan blowing against a flat wall, zero airflow going through. And for maximum airflow, this is given at zero pressure. So this is like the fan operating in vacuum. Neither of the two should be your realistic applications. So what you actually want to know is how much air can the fan push through your application, and that is hopefully a realistic application like a PC case, like a heatsink, like a radiator. And this is what the midsection of the curve tells you. So you shouldn't look at max pressure specifications or max airflow specifications, but at what's going on in the midsection of the curve, and this is where the new fan really shines. When we look at the impedance, at the resistance curves of, for example, a PC case, or an air cooling heatsink, slightly more resistance, or a water cooling radiator, even more resistance, we can see that the new fan can actually push quite a bit more air through than an NFF12 on a radiator, on a heatsink, and even slightly more air through a PC case than our current NFS12A.
Okay, great. So it's really a good blend of all those three different scenarios then, isn't it? Okay, so we've got a live demo here. I can see that we've got a bit of a simulation going on. The first one has two fans equipped, fitted to the heatsink. Yep. And then we've got our new fan attached. Well, we've just got a single fan attached to the heatsink. So can you explain this here?
Yes. We have two heating elements, 190 watt each. NHU12S coolers installed on both of them. Two of our current renowned NFF12 fans on one, and one of the new A-series fans on the other. And the results, I have to stress, are fluctuating a lot. They will be affected if I stand a little bit closer or if I back off. We have a lot of airflow going on through the hall, so you can see the numbers going up and down. But the short story is that we're getting roughly the same performance with a single of the new A-series fans versus two of the current generation NFF12 fans. Okay,
and obviously that's the temperatures, but what we're talking in terms of audio levels, is this fan going to be quieter than your other series?
We're going to ship at the same SPL. NFF12 is rated at 22.4 decibels, and the new A-series fan is going to be rated at 22.6 decibels. So it's pretty much exactly the same. When we compare these exact configurations, this one will be quite a bit louder because it has two fans, of course.
Okay, so you're getting better performance, same sort of noise level, but obviously it's a better solution.
Exactly, that's the point we need to get across.
Okay, so this fan obviously sounds like it's ideal for radiators. I know many guys out there are probably going to be wondering, are you ever going to step into the closed loop market, with a closed loop solution? Is it on the books?
First of all, yes, we're confident that this is going to be the best fan you can buy for your radiator, so it's natural to bring up the question if we could bundle it with a radiator or an all-in-one water cooling solution. And all I can say for now is, yes, this is something we're looking into, this is something we're working on, but unfortunately I cannot say much more than that at the moment.
Okay, so there's a bit of a hint there, folks. Maybe we'll see something coming very soon. So thanks very much for your time, Jakob. That's been great.
Thank you very much for coming. Thank you for watching. It's been a pleasure having you.